Okay, so welcome everyone to this webinar. We're going to talk about publishing today with Gradle, and what we can start with is a quick introduction. So my name is Louis Jacomet. I've been working at Gradle for a year and a half now, almost part of the dependency management team, and I'm here with my colleague.
So Cédric Champeau, also working on the dependency management aspects of Gradle. Today we'll discuss some aspects of what we'll see in Gradle 6, which should be out soon. Actually, you can already try the RC if you want to. And let's just jump on the topic today. Okay. So we'll cover a few topics which are actually quite common questions we have with Gradle. Basically, the topic today is about publishing libraries with Gradle. How do you do that? And this is a very common question, and the model quite changed between different versions of Gradle. And this webinar will be focused mostly around what we have in Gradle 6. So let's just get started. So first of all, I'm mentioning Gradle 6 for one reason. In Gradle 6, the default plugins now are really Maven Publish and Ivy Publish plugins. And if you are using the Maven or Ivy plugins today, be aware, because starting from Gradle 6, they are officially deprecated. So this webinar is about the new mechanism for publication. And we'll discuss what is a publication, what is a repository when you publish, all those concepts, but only using the new plugins and not the old ones. All right, so because talking is nice and slides is nice, I'm just going to switch right now to the first demo that we want to show. And the first example is actually quite simple. This is exactly, the speed file is almost exactly what you get when you do a Gradle init and you want to create a Java library.
Yes, the only thing we've removed are the comments so that we've got more screen space for what we want to show today.
So on this screen, what you can see is just a simple build script that creates Java library with some dependencies, and basically what we want to do is publish that on a repository. So the first thing I said is that we want to use the Maven plugin. So let's just do that and use the ID completion there to use the new Maven Publish plugin. So all the samples that we're going to produce today are going to use the Maven plugin. The concepts are exactly the same for Ivy. So if you prefer publishing on Ivy repositories, there's no problem. The concepts are exactly the same. The syntax is exactly the same. It's just the way you define the repository that changes. So yeah, don't be surprised. So when I do that, what the IDE would show me now is a new block that I can use that is just related to publishing. So I have this publishing extension available, and I can just start configuring publications there. So the first thing that we need to do is actually create a new publication. So I'm going to create a publications block. And for that, oops.
Yeah, maybe if you put a couple lines below.
Like this. Here we are going to define exactly what we want to publish. So here I'm saying that I want to create a Maven publication. So I'm going just to add a create block here, create, and give it a name. But I have to tell this is actually a Maven publication. So I'm going to use a special syntax here, which is the one for the Kotlin DSL that I'm using in this webinar. But if you're using the Groovy DSL, the syntax is slightly different, but documented. So go on the documentation and just figure out the difference. So if I just do that, it creates a publication, but we actually want to configure something there. So I'm opening the block, and now I'm going to create a publication. And we can see from the IDE that it requires me to give a component. So we are going to discuss what a component is later, but for now, let's just do these components, and I'm going to say that I want to publish the Java component.
And so that Java component has been added by Gradle as part
of the Java library.
Java library or the Java plugin. So it's effectively the common component for Java projects.
So if I just do that, what I've just done is creating a publication, but I still need to tell where I want to publish that. So to do this, I need to add a repository. So similar to resolving dependencies, so here you have where you resolve the dependencies from. Here we just want to say, I'm going to publish to a repository. And exactly like this, I can configure my Maven repository. And for this webinar, we're going to use local Artifactory server. So yeah, you can use whatever, Nexus, it just doesn't really matter what we use there. So let's use the URL that I think from memory is localhost, this guy / Artifactory. Oops, can we just hide this one? Okay. Artifactory / example repo local. Let's do that, yeah, so that it's not bothered. Okay, so just doing that, now I have enough configuration to be able to publish. However, we still need to do something that is not included in the template. So when we publish to a Maven repository, we know that we need the GARV coordinates, so group artifact version. And here it's actually missing. So we have the name, which is actually the name of the project, which is by default, but you can change it. But I still need to provide a group. So let's say com Gradle and set a version, which is going to be 0.01 because our library doesn't do much yet. So just doing that, I have enough to publish something, except that this repository has credentials. So I need to configure the credentials. So this is something that you probably have to face. I mean, it's very unlikely that you publish to a repository that doesn't have some kind of credentials. And of course, the credentials are really basic, admin and password. All right, and now we're set up. I should be able to test this. So let's go to the terminal. So now I'm just going to Gradle, please publish. And something has happened, but now we need to just check that it actually did something. So let's move to this. And if I go to my Artifactory server and go to this one. Sorry, the one below. And go to the repository, expand, we can see that we have published this guy. All right, so now I just want to do something a bit more complicated, but really, really simple. It is that often when you have to publish to a repository and you want to release something, you will have to do some kind of signing. So typically if you publish to Maven Central for an open source library, you need to sign. So how do you configure signing? Well, again, this is just a matter of adding a plugin there, which is the signing, not singing plugin, signing. Here we go. And I need to configure the signing. So again, when I apply this plugin, I have something here available, which is called the signing block, and I need to say something about the signatures. So signing is not always mandatory, right? Typically, if I do some publications of snapshots, well, you don't really care about signing, right? So we can tell, well, actually, I only need to sign if the version is not a snapshot. So let's just write this. So the version ends with snapshot dash snapshot snap snapshot. So this basically means, yeah, please only sign if this is actually not a snapshot. But that's not enough, right? I still need to tell how I'm going to sign. So in this sample, I'm just going to use the GPG command. So it actually uses an external process to sign, and you have something configured for GPG. And there are multiple options for signing. So go to the documentation. GPG is not just the only option available. This is just one way to configure it. And the last thing I need to do is actually tell what I'm going to sign. So sign. And here again, I'm going to use the same model. So publication components, no, publishing dot publications. And here I need to tell which publication I'm going to use. And because we have defined here something called main, this is actually the publication that we are going to sign. So because I have a new version now, I'm going to upgrade this guy, go back to the command line, run this again, and hopefully it's going to sign. Okay, let's go to the browser, refresh. How do I
refresh?
Sorry?
The first one on right click.
Yep. And if I go there now, I can see that for every artifact I actually have this signature available. So yeah, that's it, just for the first simple demo that we can do. All right. So to summarize, publishing is just a matter of adding mainly the Maven Publish plugin, set the group version, then create a publication, define your repository, URL, etc. If you want to, you can actually create local repositories, which is different from Maven, from the Maven local repository. It's just going to create a structure, a file structure that corresponds to Maven repo or Ivy repo, whatever. And then what Gradle does under the hood is that it creates a number of tasks for you to publish. So by default, it creates a number of tasks, and you have the publish, publication name, publication to whatever repository. So for our example, typically the publication name is main. So I would have something called publish main publication to Maven repository, which means please publish that to the Maven repository. And if I had a local one, it would do the same. We can have multiple publications. So if you do, there's a publish all one. And in general, publish is going to publish all the publications to all the repositories if you have multiple repositories. Maven local is a bit special, so it's a task that is a bit special and handled differently in Gradle. So you have a task called publish to Maven local, which is actually going to populate the local.m2 repository that you have on your laptop. So this can be useful in some integration process that we're going to discuss later. And the last thing that we wanted to mention is that if you care about the POM files and you want to look at the POM files or the Gradle module files or the IV files, there is a task that actually generates that. So this is something that is available under Maven Publish plugin that wasn't for the previous plugin. So this is interesting if you want to actually take a look at what is generated before uploading. Signing publication, yeah, it's just a matter of adding the signing plugin and this configuration. And then what we produce is a number of artifacts, so the jar, mainly for Java projects, but it can be something else, the metadata, so POM files, etc. Something interesting is that starting from Gradle 6, we're going to publish the SHA-1 signatures and MD5 signatures, but in addition, we also add the SHA-256 and 512 signatures. So this is going, not checksums, not signatures. So this is going to be safer for larger companies typically.
So that was it, whoops, for the publication of like the basic things you can do with publication. Now, of course, and for example, we took the example of Maven Central, sometimes you need to publish more things than just your main jar and things like that. And the idea is that Gradle allows you to add more things to be published. The first thing we're going to look at is the publication of javadocs and sources, which should be easy and required some more tweaks up to now. But you can also publish way more things, especially if you look at the recent added features of Gradle, such as the test fixtures or the optional features. What matters, though, is that in all this context, what you want to publish is not just an artifact, but it's also its metadata. And that's really what the Maven Publish plugins and the new publication system provides for you. So let's have a look again in code. I'm starting again from pretty much where we left off with what Cedric showed us. The only thing is we're no longer using signing. Makes no sense to have the process be used for the whole demos. And instead of publishing to Artifactory, I'm going to publish to a local repo so that we can potentially look at files and things in an easier way. So what I want to do here is I want to add the publication of my javadoc and my sources. And the good news is Gradle now provides an easy way of doing that. If I take the Java extension, which is provided by the Java plugin family, I can now say publish. And while preparing the webinar, we realized that the publish name might not be exactly what gets released with 6.0, so take that with a grain of salt, but the feature will be there. You can publish the javadoc and publish the sources. What that does is it effectively wires the required jar task, zip task, to make the source jar and the javadoc jars. As you know, the javadoc task was already present when you apply the Java plugins, but this time the tasks are added for zipping the sources and zipping the javadoc, and if the Maven Publish plugin is applied as well, it's also registered for publication. And so with what I've done now, and does that work? No. Okay, so with what I've done now, if I go here and we go to our demo, well, so, and if I do my publication, my publish, which is what I want, I can see that in my build repo, which is where I placed my org test publish more publication, I have now everything I expected. So I find the javadoc jar, and again, it has all its checksum files. I find the sources jar, I find the jar itself, the Gradle Module Metadata file. Again, we'll discuss exactly what it contains and why it's there later on. And of course, because I'm publishing to Maven, I have a Maven POM file. So that gives me effectively a really, really easy and convenient way of adding these two extra jars, which are, for example, required for open source publications to Maven Central. So now another interesting feature we can discuss is the addition of test fixtures. So test fixtures effectively allow you to model utility classes that will help test your library. And while you may use them yourself in your project, usually they also play a role for the consumers of your library that may have to, I don't know, mock your library or do things like that, and then you could provide helper classes for doing exactly that. We're not gonna dive into exactly the code and the details of what a test fixture should be, but clearly what we're gonna do is add them here. And so we do that by applying the Java Test Fixtures plugin. And when we apply that plugin, there we go, and there we go. When we apply that plugin, Gradle creates a number of items for you. It creates a source set that you can use in order to create code that's related to the test fixtures. It creates the required compilation and jar tasks for packaging these test fixtures, and linked to the Maven Publish once again, they will be part of your publication. So in order to show that, what do we need to do? Well, first of all, one other thing that's added is effectively a configuration to which I can add dependencies for my test fixtures. So, and what we're gonna add here is, for example, we're gonna take the assert.j library, score, and I'm taking 3.13.2, which should be one of the latest. So this here allows me to leverage that library in a class I could add. And so what I need to do here is just create a Java file, which I'm going to place in the test fixtures source set. It's Java code, and let's just put it in the package fixtures and call it fixtures.java. And that's pretty much it. Yeah, I don't care too much about that. So because I did create file and not class, I have to do a bit more. Yeah, exactly. Oh, yeah, one is too much. And so just to show, I can have a public static library, which is the class that is generated when you use the built-init plugin.
So this is from the main component.
Yeah, so this is from the main component. So I'm using a dependency on the main component, and I just return a new library. And that's pretty much it. I mean, the goal here is not to show you code and how to code test fixture. It's just to show you that we've added things here, which depends on the main component, the library. So I can access the main component if needed. And know that I have my fixture. Of course, I've changed my project. So as a good citizen, I should increase its version so that I don't overwrite the previous publication. And with that said, I can again publish.
Oh, you get some warnings.
Yeah, so I'm getting warnings. I'll get back to that immediately. Just show you here that we've got them. So the fixtures is here, and it's called test fixtures. You'll realize quickly that the name of the file actually respects Maven classifier convention. And so that file, for example, will be accessible from Maven if needed. However, the feature it will have when accessed from Gradle will be even better. And again, we'll talk about that in details later. So yes, as Cedric noted, I'm getting some warnings. And the warnings tell me that the publication main has pub metadata warnings that I can silence. There is an indication here, so we'll show that in action in a second. And it's telling me that the variant test fixtures API elements declares a capability which cannot be mapped to Maven. And that's true. The Gradle model is richer. We can't map everything that Gradle allows you to do back to Maven. However, in this context, and because I can still access them as classifier, I can say, okay, works for me, I'll just silence them. And so the way you do that is you come here and you can do a suppress pub metadata warnings. And so for example, it was test fixtures API elements. So let's be really strict. I publish again, and as you can see, one of them disappeared, the other one is still there. The idea, if you use the specific variant to silence, is that if later on you introduce another addition to your build file and it creates a supplementary variance for your publication with warnings, then you will see them instead of potentially being surprised later on. Of course, if you say, I know exactly what I'm doing, or the Maven compatibility is less important in my use case, then you can replace this by the suppress all pub metadata warnings. And again, it's another version. So this time, if I publish, the warnings are gone. They're no longer seen at all. So what we saw through that demo is effectively, finally, I could nearly say, Gradle offers you an easy way to publish javadocs and sources. But it's not only just about the jar. It also creates, and if you remember, Gradle has a variant-aware dependency model, so it will create the right variant with the right variant attributes. On the test fixture size, as we've discussed, an extra source set, the required configuration, and it does all the wiring so that compilation, running, and consuming the test fixtures can work inside your project. On the publishing side, well, the good news is nothing to do. It was all done by Gradle under the hood, and we'll understand later how Gradle deals with that. So something else that we can discuss, which is effectively a generalization of the test fixture aspect, is what people try to do with Maven optional dependencies. The problem is Maven optional dependencies are ignored by Maven. You can't access them, you can't use them. They're effectively documentation. With Gradle, instead of supporting something that was just documentation, we wanted to have a better thing. And so what we did was allow you to define feature variants which themselves can have something akin to optional dependencies, because effectively it's a part of your library that the consumer has to opt in terms of using it.
Yeah. So something we'd like to say is there is not really any optional dependency. All the dependencies are required. Yeah. They're only required if you use some specific feature. Yeah. So nothing is optional, it's actually required.
Yes, exactly. And so the things you can do there is you can have additional dependencies, but you can also have additional artifacts if required, while still doing all your development in a single project. Of course, if you prefer doing that kind of things in different projects, then that's already supported. There is nothing to do. I mean, it's just regular projects with extra artifacts, coordinates, which provide these additional features. So effectively what we're doing here is opening up a choice for developers in the way they organize and structure their code. So let's go back to the IDE. So this time, and I'm just checking exactly, I'm on the wrong one. We're going to start by the the producer. So this time, again, it's the same starting build file with the publication towards a local repository. Not much has been added here. And what I want to do is I want to start defining feature variants. And in order to define feature variants, the first thing I need to do is use, again, something that the Java blog provides me, which is a register feature. I'm going to be really creative about the name, so it's going to be called optional. And the only thing I need to decide is whether or not the code for that optional aspect of my library, the reason I'm calling it just optional, it's because it can be the name, like the artifact ID, will be my main artifact ID dash optional. So the optional is always contextual in that sense. The thing I need to decide is which source set I'm going to use. So does the code for my optional addition live in the same jar as my main code, or is it separated? You may have reason for doing either of the two. So here, we're going to do it the simple way, and we're going to say, let's just have the code in the main source set. It takes a source set, I guess.
Yeah, source sets.main.
Yeah, true. Because of the way the Kotlin DSL works, you can use source sets.main in that context, but that's that notation you've seen already. So here what I've done is I've effectively added an extra feature. That extra feature, a little bit like I've told you, it was a generalization of the test fixtures aspect. So it added extra configurations on which I can register dependencies. So let's do that. So this time, however, because it's dynamically added, I need to use the name like that.
So again, this is a Kotlin DSL specific thing, yes. So we're not insisting on the syntax there.
And so what I'm going to do is I'm going to say that it has a dependency on org Apache Commons, because you'll see it will have like really, really advanced code. Commons long 3, and I'm going to take version 3.9, which is the latest. So now I have the support for using this library and having it published as something that is not mandatory for the consumers of this code. So the way I'm going to do that is I'm going to simply create a Java class, and there we go. And that class will have, like, again, the reason here is not to get too deep into the code, but get some number. and the getSum number will do like
capital S.
well, no, that's definitely not what I wanted.
Capital. Yeah.
No.
Oh, that's this.
Ah, let's say that.
It's probably because the IDE hasn't seen that.
And I want to do something like, again, the whole point here is not necessarily the code. So that's, or is it string util and that's why I'm wrong?
No. It's I don't remember the package name. Or you could try it.
Let's see if I've got it right. So what I want to do here simply is I can start with compiling my Java code. I'm using the shortcut, so that's not it. Package org Apache commons does not exist. So what did I miss in my build file? The name. That's just
sync again. Maybe that's just the ID sync.
Well, Gradle on the command line wasn't happy, so.
But I'm pretty sure the class name is not.
Oh, that the class name is not the one?
That's the guy.
Oh, it's commons long 3.
Yes.
There we go. So that's what I was missing. So sorry about that. And now it compiles perfectly. And so now that I have that, well, that's pretty much it. On the producer side, I've done what I wanted to do. I've got an optional feature that has an interesting method. So again, let's publish it. And that's it. So now that I've published this, I can start consuming it. Because here the interesting aspect, of course, is to make you understand the kind of things it allows from the consumer's perspective. So on the consumer side, well, what I want to do is I want to say that I effectively need, as part of the implementation of that library, I need to consume my thing. And so it was publish feature 00.1. So that's what I'm saying I need to consume.
So that's your producer, right?
That's my consumer.
That's not the optional thing yet.
No, it's, yeah, I'm consuming the library as it is defined. And so what I can do now is I can have my wonderful consumer class, and in my wonderful consumer class, I can do a public boolean, useLib method, and in that useLib method, I can return a new library dot some library method, which is effectively what we had as the regular thing. And of course, it matters to write tests. So what I'm going to do is I'm going to add a test here. So I'm adding a test, and my test is simply, again, new consumer. And I can do an assert true that the consumer dot useLib method should be all good. Okay. And so now if I go back here and I go to my consumer feature and I run my tests, it passes, but that's expected. What I've showed you there is the basic dependency management of Gradle. So let's move to what's really interesting in this concept. And here we've said that the code that uses the optional, the optional aspect of the code is part of the main jar. So it means that I can do something like I can use the optional bits directly. And so I can just do return new optional feature. Well, I don't need the new, it was a static class, a static method. Yeah. There we go. Get some number different than -1, because that's what I expect. I mean, I expect foo to be in foo, foo, foo. And so, of course, I can add my test. And if I add the test, it's again quite simple. I've got a new consumer, and I'm asserting true that the consumer dot my optional bits should be all good, really? So let's check. The first thing we can check is that I can compile this code, so my library code. And my library code compiles fine, because as we've said, the optional bit is part of the main jar. However, if this time I try to run my tests, I'm getting an exception, and the exception I'm getting is a class not found. And of course I'm getting the class not found because by default,
Dash configuration.
If I look at the runtime class path, or the test runtime class path, there is no commons long in here. It's not part of the test runtime class path. And that's because the producer decided, well, only very few of my users will ever need that dependency. So I would rather they declare they need it and use the specific aspects that are linked to it, instead of always having it in the class path, potentially creating conflicts, like growing your application size and all of that. So what do I need to do from the consumer's perspective is I need to add the dependency. And the way I do that is I can duplicate the dependency line because I still need the regular component, but I need another component. And the way I do that is by saying that I need capabilities. And I then say that I require a capability. I require a capability, and the capability I require is based, like we said, on the name.
You don't need the capabilities block. It's directly in the configuration, I think.
Yeah? Well, I'll leave it like that. I know it works that way. So here, what I'm effectively saying, let me get rid of the left-hand side, is that I also want in my graph an aspect of the publish feature which is declared with an additional capability that will provide me then the optional dependency. And indeed, if I go back here and run my test, this time the test passes. And if I run again the dependencies report, well, we can see that effectively our common slang showed up. So now we've got what we expect. So that's pretty much the benefit and the use and the kind of things optional features allow you to do. So again, a quick recap. What you do is you register the feature. The choice of the source set indicates whether or not the feature will also have an attached artifact or whether it will just be about dependencies. It again creates all the configuration and wires them. On the publishing side, as you've seen, we didn't do anything. It's taken care of by Gradle. Again, details to come like really soon this time. And on the consuming side, I need to require the capability. And so selection happens through the use of capabilities. We had previous webinars that described a little bit more the concept behind capabilities and also the documentation that comes with the 6.0 version of Gradle as an enhanced and deeper description of that feature. One thing that we can mention is that when you're building such a library, you may want to declare that some of the optional feature or the feature variants are exclusive. And the way you do that is by declaring that they all have a common capability. And by having that common capability, Gradle will ensure that consumers have to make a choice between one or the other module that provides the capability. If you want to know more when the slides will be published, you'll have links here to the full documentation on both text fixtures and feature variants.
So just a small comment regarding the optional features. So you just used one dependency, but you can add as many dependencies as you want.
Yes, and you can have them on the API as well, not just on the runtime. I mean, that's all you effectively have the same flexibility as Gradle generally. Back to Cedric.
Yeah. So what you've shown us is just usage of something that is called the component model. So we have components, we talked about components, we talked about publications. What does that mean? Actually, it's quite simple if you have that diagram in your head. So if you take a project, so Gradle project, it has a number, it defines a number of components. So this is this one. And each component declares a set of what we call variants. And each variant is what? A number of artifacts and dependencies. So typically in the Java ecosystem, what you get is something that looks like that. So when we say in the publishing side from components Java, actually what happens is that Gradle defines a component, a software component that is named Java and has a number of variants. And those variants, maybe you found a name during your day-to-day usage of Gradle, but we have this name API elements and this name runtime elements, and those correspond to different variants of that Java component. And when we talk about separating the API from the implementation of a component, this is how it is defined. So you can say that my API actually provides some artifacts, but also some dependencies. And you can see that typically in the Java ecosystem, the number of dependencies that you would have on the API is lower than the number of dependencies that you need at runtime. So we have a Java component and a number of variants. In practice, there are more variants. We won't get into the details of the number of variants that you have in the Java component, but when you added features, what magically happens is that we create additional variants for all the optional features that you can consume.
And because we create them on the Java component, well, the publication is just about let's publish all the variants.
Exactly. So in practice, often for a single project, you will have a single component and often a single publication. So this is something that is really, really common, the one-to-one mapping. In practice, Gradle is not limited to that. You can define as many components as you want and as many variants. Well, this is really not limited, but it's a good practice to just have a one-to-one mapping. All right, so why do we do that? Actually, there's an interesting aspect of having the component model is that it creates safe boundaries between the different sub-projects of a single repository. And we'll come back to that a bit later. But what is extremely interesting is that the artifacts that we have are actually bound to this concept of variant. So we have a variant that provides a number of artifacts and a number of dependencies. And those all belong to a single component. And the consequence, and one of the interesting aspects of this is that we can answer simply a question that is often asked is how do I share the output of a sub-project task to a different sub-project, right? This is a question really frequently asked in Gradle. And if you ask that to most users, the answer would be exactly what we have on this slide, which is, yeah, that's easy, just do my subproject, get the task, get it by name, some task, and I'm all good, right? Except that no, you're not. So if you do that, actually many people don't know that it's totally unsafe to do that. So it's unsafe for many reasons. The main one is that you cannot really rely on parallel execution if you do that. You have lots of changes, this wouldn't work. And the other aspect is that actually this is really poorly modeled. What is this task doing? What is its output? What does it mean? Well, who knows? So today you can know what you do, but tomorrow that's not really clear what you intended to do there. So we will try to improve that a bit. And to do that, I'm going to show a demo of the publications between sub-projects. Yeah. So I need the cross-project publication demo. And I can reuse this one. All right. So again, the setup is really similar. We will have a producer, a consumer, and I'm just going to make sure that this is step one. Yeah, that's fine. Okay. So basically what you have to know is that we have many options, and those options depend on what you intend to do. So in this demo, I'm going to show it from the simplest thing that you can do to the better model solution, which is variant aware, and eventually we're talking about publication. So the idea is that maybe this output of a task, yes, you want it to be reusable between projects, but maybe you want also that to be publishable on a Maven repository or Ivy repository, whatever. So how do you do that? So the simplest use case is just you have a task and you want to publish that to a different project. So make a jar available. So this sample is just saying, I want to create, say, an instrumented jars. So you process the classes with whatever library you want. And this is actually not exactly the same content as the jar. It has some logging added automatically by a bytecode processor, whatever. So I need an instrumented jar, and this is what my consumer wants. It doesn't want the regular jar. So to do that, on the producer side, what I'm going to do is that I'm going to create a configuration called instrumented jars, and I'm going to see this is meant to be consumed. So I need to say this is meant to be consumed by someone else. And the resolved aspect is just saying, yeah, this is not intended to be used within my project. This is really for consumers. And again, you can do whatever you want with the dependencies, but if I extend from the implementation and runtime only configurations, basically I inherit from the dependencies of those configurations. So depending on what you need to do, you can extend from whatever you want. So this is just creating something that is going to attach some artifacts to.
Yeah. And so clearly so for example here, the extension from the configuration, it gives you the same class path as the runtime class path of the main jar.
Yes.
That's what it does there.
Effectively, yes. So I want to create a jar. This is a demo, so basically just create a jar which is not instrumented, but just create this classifier. So it means that this task is going to create a jar which classifier will be instrumented. And this is what we want to expose to the consumer. So I create the jar, and now I want to attach this jar to the configuration. So it's just a matter of calling this outgoing method with the artifact method and pass it the jar. And you can find that here I'm using the task directly. It's not the file that I'm using, but really the task. So Gradle does some magic wiring there. And the magic wiring is that if you ever want to consume that, it's actually going to execute the task for you. So you don't have to explicitly call the task, it's going to do the right thing for you. All right, so how do you show the bar? Command one, thank you. All right, so now on the consumer side, what I want to do is use this instrumented jar, right? So this is actually pretty similar what you have to do on the consumer side, but then instead of creating a configuration that is meant for consumption, I'm going to create a configuration that is meant to be resolved. So I want to resolve the dependencies that will come from this producer. So I create just this flipping the flags. So this one is not consumable, but it's resolvable. Again, we discussed that in a previous webinar. Don't focus on this aspect, that's not the most interesting one. But now, how do I declare my dependency is just using this. So my configuration adds a dependency, which is a project dependency on my producer here. And I'm saying, yeah, the project path is producer. And I use this magic thing saying, actually, I'm going to directly depend on this configuration of the producer, right? So this is the simplest thing that you can do. And if I go on the console, So I need to go back to this cross project publication project, and then I'm going to do Gradle. So what's the name of my task again? Resolve instrumented classes. Resolve instrumented classes. I'm lazy. What it's going to do is show me basically what is the class path related to this. And what I get is, yeah, the instrumented jar. So this is exactly what we wanted. So if I had some dependencies defined on the producer, we would find all the dependencies jars there too, right? So that's the simplest thing, really the simplest that you can do. However, it has some drawbacks. So this one, which is still highlighted, is quite a major drawback, where this is actually hard-coded. I have to know the name of the configuration from the producer there, which may be fine, but yeah, that's not so cool. The other problem is that maybe what I need is not exactly this. Maybe what I need is something different, where I want the instrumented jars when I'm going to run the application, but something different when I'm going to compile. I mean, for compilation, I can use the regular jar, and I don't want to spend, I don't know, an hour instrumenting my classes just to compile. So separate the processes. So let's improve this a bit and go on the second step, which is about defining a better model for our producer. So because it's going to be a bit more complicated, now I did a special trick. I moved from an inline definition of all the configurations, the outputs, to a build source plugin. And this is actually a plugin which is defined in build source here. So if we go there and we go to our plugin class, which is the version 2 for now, I have something which is a plugin, and in a plugin you can do basically everything you can in a build script except that it's scoped inside the plugin. And I'm doing exactly the same thing as before. I need to create a configuration, but this time I added things there. I'm adding things that Gradle knows about and that as a plugin author you might want to be aware of. I'm adding attributes, and attributes are the enabler of variant-aware dependency management in Gradle. So this is a jar, so this is something that is usable in regular Java projects. So all the attributes that we get there are something that you would find on the regular runtime API and all those configurations that you have on the regular Java project. The real difference is the last one, library elements, where I actually added a value here which Gradle knows nothing about. This is just a new value. Instrumented jar is a new value there. Regular value would be typically jar here, but I'm just saying this is something new. And this is it. I mean, I didn't change anything in the way we create a jar. I'm just changing the way I define this configuration, but now I need to change my consumer. So I'm going to go to the consumer side, and the first thing that you can notice there is that now when I define the dependency, I don't have to set the actual configuration that I'm going to use. Gradle is going to do the magic for me, okay? So the magic here is all those attributes, and we switch from a model where we explicitly say, please give me this configuration, to something that is going to be smart and choose the right one depending on the context. And where is the context defined? It is actually in the configuration that is going to be resolved. Mm-hmm. So you have the runtime class path, you have the compile class path, you have the test compile class path, whatever. And here, actually, as a consumer, I only want the instrumented jars in the context of the test runtime class path. This is the only use case. So I don't want it from that compile class path. Doesn't make sense. It's only when I want to run the test that I want those instrumented jars. So I need to say as a consumer, hey, yeah, on the TestRuntime class path, actually what I need is this instrumented jar attribute. So I'm saying, yeah, take those jars, but if you have one that is instrumented, please use it. So there is a bit more in the producer to make this happen, but this is basically the setup. So doing this, what I have is an explicit mention of the TestRuntime class path. So if I go back to the console and run this, I should see a difference in the resolve configurations, right? So when I'm going to execute this task, I'm going to dump the testCompile class path and the TestRuntime class path, and let's see what it does. So same command, resolve, but now we can see that this one is actually the compile class path, and I'm still using for the compile class path directly the classes directory of the other project, but not the jar. It's only using the necessary bits for it to compile. So it doesn't process the resources, it doesn't need to generate a jar, so it improves the parallelism if you do cross-project parallelism. But for the runtime class path, we said, hey, sorry, but I need the instrumented jar, so give it to me. And now, yeah, it just resolved everything. So that's nice, because now, just with a single dependency declaration here, depending on the context, I am choosing a different variant. And what you see here is exactly what Gradle does internally when you have compile class path, runtime class path, and actually sometimes it would build a jar, sometimes not. It does only what is required, and this is exactly how it works. So this webinar is also about publishing. So now, what if I wanted to have this instrumented jar available for my consumers? Yeah, because maybe they have some tests too, and they need this jar. And this is typically something that is hard to do with Maven or even with Gradle today. I mean, yeah, I just need to publish this, but how is it possible? So again, I'm going to switch to the last step of this demo and just look at this new implementation of the plugin. And I'm going to do what the feature variants do, what the test fixtures do, which is adding some more artifacts. So let's look at the configure publication method. Not this one first. So I have I have two options. The first option that I have is I'm using the Java component. I'm using the Java plugin. So maybe I want this artifact to be available always when I publish the Java component. So you can ask Gradle for this Java component and use this special type, which is ad hoc component with variants. Again, refer to the documentation, we post the slides, etc. But what we want to say is that, okay, now when I'm going to publish that to a repository, I am going to add a new variant. And this variant needs to be mapped somehow to Maven, right? I need to say what does it mean for a Maven consumer. And what I can tell there is that this is going to be mapped to the runtime scope in Maven. And for the dependencies, well, mostly in Maven, they wouldn't make sense as a regular dependency. So let's make all the dependencies optional, which is exactly what the optional features are doing. They're doing this. So they map to the compile scope or runtime scope, depending on the variant, and then they map all the dependencies to optional. So if we do that, we have something which is compatible with Maven in terms of the produce pom file. It's going to have dependencies optional, whatever, and something that Gradle would be able to consume, but consumers would be able to get this using exactly the same syntax without having to explicitly use a classifier or whatever, right? So this is the first option you have. And just for the completion, for the record, we said that a project can define multiple components. So this is how you would create a custom component that is not the Java one, but something different, and just have a single variant here, which is the runtime, which is the instrumented jars one. So here we don't really care about what it's going to do. I just want to show the last thing because we want to publish that. So let's do publish. And we're going to take a look at the output of the producer, build, repo directory again. And we will have this org Gradle webinar dependency management thing. On the producer side, we have the Maven metadata, which is the regular thing listing all the versions. And then for this specific 1.0 version that we have, actually, I have published my jar now. So this is on Central, on Artifactory, or whatever you want. But this is accessible for Maven consumers as a classifier. And this is accessible thanks to this module file to Gradle consumers without any modification on the consumer side. All right, let's switch back to the slides. So yeah, just a summary, different options from the simplest to the most advanced that you probably have to do if you're a plugin author. Create the configurations to attach the artifacts. On the consumer side, define a configuration to resolve. Maybe you can just use the runtime class path. I mean, you don't have to create one. Declare the dependency. So this one is the simplest, using the configuration notation, but it's explicit. Yeah, not super nice. And then we improve. We create a plugin on the producer side. We declare all the attributes that let Gradle find the right variant in the right context. And then on the consumer side, I can just use that project notation. Okay, so when I do that, I can split the different contexts. I can declare something on an existing component, or I can create ad hoc components. But now, you talked about the test fixtures thing, right? Which is using exactly the same mechanism internally.
So effectively what we saw there is the logic that's behind the text fixtures, behind the optional feature. It's the raw mechanism that we hope to offer to plugin authors so that they can create rich components for use in their context.
But again, this is important to do if you want to have safe publication between your projects and create safe boundaries. So, but yeah, you talked about the test fixtures, but there's something that I don't like there. And I'm going to explain why. So, you told me, yeah, this test fixtures is going to be published, right?
Yes.
I don't want them to be published.
Oh, well, I think you've got an option.
So, okay. So typically for the test fixtures, yeah, that's fine. I mean, in a multi-project setup, I want my consumers to be able to use the test fixtures, but I don't want to maintain that as a public API for external consumers. So I just want to exclude all these test fixtures from the publication, and I don't want them to be on the repository. So again, we can use this ad hoc component with variant API just to say, hey, actually, for the test fixtures API element variants, skip it. So you would have to do it for the API elements, but also for the runtime one, right? So currently in Gradle, you don't have a shortcut method to do it, just to disable publication of test fixtures. We're probably going to offer that in a future version, just as a simpler, just like, yeah, publish javadocs or whatever. So it would be ignore publish test fixtures. So just be aware that you can do that, so skip something. Also, we want to mention that there are different plugins for publication that do different things. You have published on Artifactory using the regular Maven plugin, but if you use the Artifactory plugin, what it does in addition is that it's going to publish some metadata about the build itself when it uploads to Artifactory. So it builds on top of the Maven publish, but adds some build information. Something to be aware of. As of today, those plugin, Artifactory plugin and the Bintra plugin that I'm mentioning here do not support Gradle metadata. So, yeah, you have a pull request, right, to fix that?
Yes.
Cool. So it's going to be fixed soon.
Yeah, fingers crossed.
Let's move on metadata now.
Yeah, exactly. We've been talking about all these nice features and everything, and I know most people understand and know about the POM model and realize that a lot of things we've just covered just can't be expressed. And so the way Gradle sorts that out, it's by having its own metadata formats. So clearly we do support Apache Maven and Apache Ivy metadata formats. Of course, we will only publish POMs to Maven repositories. We will only publish Ivy XML files to Ivy repositories. And all the options that you want in terms, for example, of the Ivy flexibility are available for you. Have a look at the documentation in how you can customize your Ivy publication if that's what interests you. However, with Gradle 6.0, we will always also publish a Gradle Module Metadata file. It will be published in addition to the native, I would say, metadata formats of the two kind of repositories we just described. And what it does is it's the piece that allows all the features we've discussed to work because it carries all the information about the variants, the dependencies, and all of that. So let's have a quick look. For example, so we saw from publication that you've got the POM, the module, the jar, and here, for example, we're taking the example of the Jupyter, JUnit Jupyter API. You've got javadocs and sources. The information in the module file, it's effectively about, for example, these javadocs and sources additions. But then also, as we'll see in some of the examples, JUnit started leveraging some of the upcoming Gradle features. And so, for example, as you see, the javadocs elements is a real variant. It clearly states that it's a different kind of category. It's no longer a library, it's a documentation item, and the documentation type is javadocs. And that allows consumer, again, similarly to what Cedric demoed, that allows consumer to dedicate consuming configuration for that special purpose. So here we're creating a javadocs configuration, giving it the documentation and javadocs attribute, and then just by having a regular dependency in a way on the module, but because it's in the javadocs configuration, when we resolve it, we will resolve the javadocs jar and not something else. Similarly, what they do with JUnit, what they will be doing with JUnit Jupyter, because 5.6 is the currently under development version, in their API elements variant, which is the variant used for the compilation, they will have a reference to their bill of material. And that allows features like alignment. So with that published and with the BOM itself containing reference to the different elements that compose the JUnit distribution, when you do something like implementation on the JUnit API with a given version and then implementation on the engine with a different version, Gradle will realize that they're linked and they're supposed to be used with the same version. And so there will be a version alignment to 5.6.0 for Jupyter Engine without you having to do anything. Of course, if this is what's written in your build file, you probably should correct it. However, sometimes this may happen through transitives, and here, well, it will work as well. So what the metadata format gives us is Gradle, we've had webinars, the documentation mentions them for a while now. Gradle has the support, for example, for dependency constraints. This is something that only the Gradle format can represent fully. They're translated to the dependency management entries in Maven, but of course you all know that dependency management entries in Maven have a special behavior, whether they live in your current project or whether they live in one of your dependencies. Their scope is not the same. While in Gradle, it's consistent. You also can use platforms. You can use all the features of the rich version constraints, so strictly, require, prefer, reject, all of that is published as part of the Gradle metadata. The component capabilities that we discussed, the feature variants, so the fact that you can effectively add these extra variants to your project. This is all part of what the metadata format provides. And of course, for example, we work hard to maintain compatibility with the other tools. And that's why you've shown in all the examples we've used so far that the format, the name of the file, the additional files that are published respects something that Maven understands by mostly leveraging the classifier. And that effectively allows Maven consumer to still benefit from these binaries. However, but just the same if there were like optional dependencies in Maven, they will have to do their own work around the metadata such as dependencies. And the one thing that's possible, though, is that Ivy, effectively, because it's flexible in terms of configuration definition, Ivy fully supports the feature variants, because there what we're doing is we're adding a configuration with or without specific artifacts and with or without specific dependencies. So now, an interesting exercise that we started doing while working on Gradle 6 was, okay, what if Gradle 6 existed? What could it do for popular libraries? And so one example that we took is the Guava library. And you all know that Guava effectively encodes the Android or the GRE version in its version. So this is not a classifier. This is part of the version, as can be seen here on the path. And the way that works is effectively the Android version is kind of the Java 7 compatible version, while the GRE is a higher release requirement, 8. I think it's 8 still today. And the way it works is because it's part of the version, if you only require Android, well, you'll get the Android version. However, if you require the GRE version anywhere in your graph, well, that's what Gradle will upgrade to, because GRE happens to be after Android. Of course, as a consumer, that may not be what you want. You may have strict requirements for using the Android version, and you would like to know at build time that somebody is bringing the GRE version and then potentially breaking your application. And so, well, that's what you could do. Instead of depending on GRE or Android, you would use just the version, and looks like we've got a typo here, because I removed it in one place, not in the other. But you would just use Guava 28.1, and depending on your target compatibility version, we would select the right one, because this would be an attribute that would be custom to each specific item. And as you can see, it would mean we would effectively respect what Guava produces. So you would still have the regular production of Guava, but for Gradle consumers, you could also consume the version without any suffix. So this is the kind of possibilities that are opened by the richer metadata format, and that's why Gradle 6.0 starts publishing it all the time. So that was a lot of content.
Yeah.
However, we also need to talk a bit about strategies.
Yeah, so quickly, so strategies. So one of the problems that you often face in an enterprise world is what is the difference between what I declare in my build file and what is actually published. So typically you have a dependency on commons lang and you say in your build file, yeah, I'm using 3.3. But by the transitive dependency game, actually what happens is that you resolve 3.4 and what you published was 3.3. So your consumers are going to use 3.3, but what you tested with was actually 3.4. So maybe that's a problem, there's something wrong there. Or worse, you are using dynamic dependencies in your build file. So you say, yeah, I'm using 3+, and who knows what is going to happen when I'm going to publish that, right? I mean, the consumers could use a different version from what I'm using. So actually, when you publish this, Gradle offers you two different modes and lets you choose what is your intent when you're going to publish your component. Do you actually intend to publish what you declared in your build file, or did you intend to publish what you actually used when you tested your library? So this is the difference between what you declare and what you publish. And there are pros and cons on each of the different strategies. So typically, if you use the declared versions, this is effectively what you wanted to express, right? You have in your build file, I'm using 3.3. Maybe it's not going to be the case, but this is what you intended to say. It's even more important if you use rich version constraints, like you say, yeah, I'm going to use something which is between 3.0 and 4.0, and I prefer to use 3.3 within that range. So you express everything you want, but yeah, who knows what the consumer is going to use. The problem is that today, at least in Gradle, you don't have a good way to figure out if this is the result version. So if you use a single version, you have this upgrade, you can easily miss that something changed and was bumped. So you have to be very diligent in terms of the dependencies that you declare, or use fail on version conflict, whatever, to be able to notice that you have an upgrade. So the results can be very different. If you use the result versions, well, actually you get rid of that problem. So that's cool. So what you resolve is actually going to be what your consumers are going to use. So for consumers, it's much more stable, but it has a number of drawbacks today. So typically, it's a lossy mapping. So if you publish the result version and that you use the range, well, maybe that range meant something. If you say, I'm using from 3 to 4, and that when it's published, it's only 3 because that's what you resolve, well, you lost that information that you wanted to use something between the 3 and 4. So also because you have this game of grades, yeah, sometimes the what you publish is going to be unintentional. And it's always, yeah, we like to say approximate, because what you're going to use when you resolve is the result of what? The runtime class path, the compile class path. So you never know exactly what versions you're going to use. And one last problem that you can have if you use features like dependency substitution, composite builds, or whatever, is that you can have a module which is declared in your build file and that actually is not resolved because it's substituted by something else, and then you will have a mismatch between what you produce and what is actually used by the consumers. So for rich versions, this is what I explained. You can have something in Gradle that says I'm using strictly 3.0 to 4.0, and within that range I'm using the prefer, which is 3.3, but if you publish that with the resolved versions, then you lose that information. So we still maintain the strict versus require constraint, but it's still lossy mapping. Okay, so how do you do that? How do you choose between those two strategies? Again, it's on the publication side. You have something called the version mapping, and what you see there is a way to say, I want to use the resolution results. So the easiest way to configure that is just let Gradle use its defaults. It's going to choose the right configuration to resolve for you, and it would just pick up the version numbers from there. If you don't want that and want to use a specific configuration, you can still declare explicitly what you want.
And so here effectively what we're doing is we're making sure that both the result version of the API and the runtime variant will always use the result of the runtime.
Yeah, exactly. So you may wonder what's the relationship with dependency locking here. Just a small note, dependency locking is about your own project and nothing else. So it is about build reproducibility. So you say at day 1 I'm building with those versions. If I come back in a month, it's going to be the same versions that I resolve. But it says nothing about the consumers. So they don't see the log files. So they could use something very different. So if you use dependency locking, you can use the published versions in addition, and that would make a lot of sense actually to do that. Yeah, in the future we plan to improve a bit what we've done, just because typically when you say that you have a range and you replace it with a fixed version, well, that's not super nice. So maybe we can do a bit better and tell you, what the range preferred version is actually what you resolve typically. Let's go.
So we talked about a lot of things, but then what should I do as a library publisher, whether it's internal to a company or a public library, an open source library that's supposed to be consumed by a larger group of people? Well, the first thing is Gradle is agnostic. Like the version of a project is effectively just a property on that project. And as you've seen through the different demo, the where to publish is also something that Gradle, well, it's up to you effectively. So the first question, of course, is which version should you release? You could use the snapshot convention from Maven. The only thing, of course, is that for your consumer, you're effectively creating a changing dependency. So reproducibility will be a problem. You could decide to go with unique releases, but then, of course, you're creating work for your downstream consumers because they have to update the version. Whether it's automated or manual doesn't matter. The version needs to be updated. You've got the where to publish. Like in an organization, you've got multiple options. Developers could use the Maven local repository. While convenient, it has a number of issues. I'll refer you to the Gradle 6.0 documentation on that topic. Clearly, one advice, if you do use Maven local, use repository content filtering and target the snapshots you're supposed to get from it and nothing else. You can, of course, publish to a repository, whether it's local or remote, but that requires more infrastructure. You have to pay attention, you may have to clean it up after a while, etc., etc. So with all of that, well, then the strategy really is, in a way, up to you. You can live with the dash snapshot limitation. You know, you understand what it means. You accept them, but it's much easier. You could say, well, because of the limitation of the snapshot strategies, I'm going to use unique releases, consume them through dynamic versions, use locking so that I can do control upgrades instead of, oh, the latest is out, it's there, which is effectively back to the snapshot problem in a way. And of course, you could even say, and for my downstream consumers, I'm publishing fixed version through the publication of the result version. So once you've done all that, then comes the integration. Like, as a developer, my company chooses a strategy, but then how do I work locally? Well, clearly, one thing is publication and releases, but also, and that's where Gradle is interesting, Gradle has alternative options. You could compose the builds. So suddenly, the producer and the consumer become a single build, and you can work on them at the same time. Of course, you'll have a release stage, but the release stage might be after testing and validation has completed. You could also leverage source dependencies, which is effectively, instead of compositing, you're really pointing to a remote Git repo, and you're grabbing what needs to be built as part of your build. So for doing all of that, Gradle provides all the features we've discussed tonight, but there are also external plugins. And these plugins, what they do is they choose a path, they have opinions. And so, for example, the Nebula release plugin will give you a number of options that the plugin authors deemed interesting. It integrates with Git, it will so create versions that are named after your branches, it will allow you to create different kind of releases, final candidates, snapshots, unique snapshots, etc., etc. So that might be, in a way, what you're looking for, because then you don't have to implement it in your build. And of course, the larger topic there is really the whole multi-repository development. Because that's where, inside an organization, you have to decide. And we can't cover all of that tonight. I mean, we're already a bit over time. But clearly, stay tuned. We will be thinking about a webinar on this topic. It might be a longer span between this one and the next one, but that's also something we believe Gradle should help you do. In conclusion, if you're publishing, please take a look at Maven Publish or Ivy Publish. Replace the old Maven or standard upload archives. Look at what the Gradle Module Metadata can offer and really leverage it. We think it's an exciting time for metadata and providing a better modeling of the whole dependency management system. And that's it. Thank you.
Thank you.
So we won't, we will do questions, right?
Yeah, there are lots of questions. I don't know if we have a lot of time, so we will answer some questions after the webinar in any case. But speaking of the questions and the last slide, can you come back to that slide? Because this is an answer to one of the questions we have, and I'm seeing here. So someone is asking, well, this looks like something that Android could use, right? And actually, yeah, they are working on it. So they are working on using the Gradle Module Metadata to publish ARs, to publish all the different kinds of artifacts that exist in the Android project.
So if you look at the documentation for the upcoming Android 3.6, they're starting to adopt Maven Publish. And in order to do that, they're also starting to create multiple components. As part of the, and so you'll have to pick also what you publish, etc., etc.
Yeah, and we had beta testers for a month in the Kotlin native world. So Kotlin is using that for really long time now. So this is not really super new for those familiar with the Kotlin native world, because this is exactly what it leverages. Okay, there's one saying, yeah, guys, this is quite complex. Yes, it is. We have lots to say in a single session, but the idea is really to show what the internals of Gradle do. Most people don't have to face that in reality. You just use the DSL that we showed you in a simple example in the beginning.
Yeah, the thing is, in order to make the publishing presentation interesting, we wanted also to go a bit beyond regular Gradle use and show what would be possible for Gradle plugin authors. And as where you can find more information, well, we've worked hard to revamp the whole dependency management documentation with 6.0. So head out to the documentation of the first RC and take a look and let us know.
Yeah. So one question is regarding this using source set keyword. I just want to expand on that. So that was related to the feature variants, so what we call the feature variants and optional dependencies, and what it means to have using source set there. So this is a choice, right? Often when you develop an optional feature, sometimes it's just because it's too hard to split the project into multiple different submodules because code is tangled. But you know that this feature, well, which is in the main source set, is actually used by a small portion of users. And yeah, you don't want to put that dependency for everybody. It doesn't make sense. So this is where you would use using source set main, because actually the feature lives in the main source set. However, you can use different source sets there. It doesn't have to use the main source set. So you can have a single module and the feature developed in its own source set within the same project. So this is a choice whether you want really to have it as an external module, different subproject, and if it's too hard to do, which would be the right way to have optional features, it's just different coordinates, you import that. But if it's too hard, then you have this feature, which is, yeah, I mean, this has support for different databases, and if you want to use this one, yeah, you need to pick up all those dependencies. And for those of you who are familiar with the Spring ecosystem, this is something that they have a lot. Like you have all those giant POM files with 100 optional dependencies. Who knows what they are used for? Nobody knows. I mean, you just have a list of dependencies, but what they are used for, we don't know. With the feature variants, what you can do is really group all those into features, and instead of saying I need this dependency plus this one, plus this one, plus this one, just say I use this feature. Then all the dependencies come.
So we had a couple of more down-to-earth questions. The ID we're using is IntelliJ. Can strongly recommend it. Like for doing Gradle code, the community edition is more than enough. So go with that. But if you like it, consider.
There's an interesting comment. Yes, I use a password, a plain text password in a build script.
Yes, of course.
Don't do that,
no.
Of course.
The thing is, for here it was just simpler. And as you've seen, the admin password, if you've installed and launched an Artifactory, these are the default. And it's a Docker container that's going to be destroyed after.
So typically the best practice, well, a common practice is just to have the key in your Gradle properties file of your home directory, not the one of the project, of course. So
there is a question about how much of what we discussed today is applying to publishing Gradle plugins. Well, most / the publishing of a Gradle plugin needs some love for real. And so that's going to be one of the upcoming steps on our side.
So we have on our mind the idea that using this feature, well, this variant-aware resolution, you could use Gradle 6 and build plugins for Gradle 4, 5, 6. And this is exactly what this is about. I mean, the consumer should have to know it's the engine that should choose the right version of the plugin based on what you're using. Well, yeah, we're way over time, so I guess we will just stop here today and answer the remaining questions.
We'll have a look at the remaining questions.
Thank you all.
Thank you.
And see you next time.
Bye-bye.